Hello to my class and to anyone who else may be watching. As promised, I have my Intro to Memory Physics video here today. We're going to be going through Volatility 3. So I'm going to be introducing how to install the new Volatility over the last older Volatility 2, some of the differences between them, how to run it with Python specifically, the basic options of reading a memory file, some symbol table stuff, and we'll be going through some of the fun plugins that Volatility 3 has and how to use them, and what kind of useful information we can get from a memory image. I'm not going to be going into memory acquisition in this video. Maybe in another video I can do that, but it's really kind of a pretty simple process. You basically just run one of these programs and hit acquire, and then you have a memory, a capture of your RAM, basically. So each of these tools, FTK Imager, works on Windows, and I believe it works on Mac. Maybe double check me on that. I prefer Windows PMEM personally. It's a command line tool, really simple to use. Lime is good for Linux acquisition. That's like a kernel driver that you can install and just capture memory with. And for Macs, I found something called Macquisition. I'm not too familiar with how Macs do stuff like this. It seems like this one was the popular tool that I found, but looks like this was owned by Cellbrite now. So maybe there's another Mac tool out there that you can find that's better. I do have a whole list of tools in my references here, which I'm going to post all of this in the description. But the probably the main one you want to look at is this awesome Memory Forensics GitHub. Has a ton of way more information than I could possibly fit in this video on acquisition, tools for analysis, and things like that. So that's where I'm getting all this stuff from. Okay, so why am I doing all this? Well, last week we had a research question that you guys kind of passed up on, which I don't blame you, because this is probably the hardest of the three. And the question was basically to investigate data elements that could be found on a storage device but would have to be collected from primary memory. In this video, I'm probably going to go into both, like what things you could get in primary memory that might also be on the storage device. This is definitely kind of a complicated topic. We're going to go more into this with Volatility. Volatility is kind of the tool that you use to carve up these memory images. All right, so I'll go through a little bit of how that process works. Follow along with my little guide here. So first off, why Volatility 3? Why not the traditional Volatility? Most of the guides out there that you're going to find are going to be on Volatility 2, which I do have as in binary form. Oh, let me close out of this stuff real quick. All right, so I have one of the binaries for Volatility 2. Let me maximize that. This one, where is it? This one right here. I downloaded this straight from their GitHub page. This is Volatility 3. So Volatility is here. As you can see, it hasn't really been updated in a while. They're not really developing this one anymore, but a lot of people still use this tool. If you're curious about this one, you can find it in the releases on GitHub somewhere. I didn't want to do Volatility 2 for this video, both because I wanted to learn Volatility 3, but also because there's some problems with Volatility 2 that I kind of ran into. Specifically, when I tried to run it on a big image. So the image my RAM, I should say, is 32 gigabytes. I'm a bit of a crazy person. I have more RAM than I really need, but I kind of basically just did a capture and tried to go through it and with Volatility 2, and I got something kind of like this. So if I just try to do image info, which is the basic command that'll tell you about the command, right? mem.raw is the file that I saved that big image to. This one's gonna, I could let this run, but I would be keeping you here till like the end of time. When I ran this on a 4 gigabyte image, it took me about a half hour to an hour. So it's not really great at those big images, or at least not anymore. Maybe there's some change with Windows 10, Windows 11, I don't know, but whatever it is, it doesn't really work for big images. Whereas Volatility 3 works really, really well. I'll show you real quick how quickly it's going to work. And remember, this is a 32 gigabyte image. The corresponding command for image info is now windows.info. All right, I'll let this one work. Still is a little bit slow, so I'm not going to have you sit through here for all my commands, but just for this one, just so you get the idea of how it runs. Okay, so we have our image info, and we get a whole bunch of stuff about the image. First thing, we get a little link to the symbol file table that it used. not going to talk about symbol tables in this one, but that's kind of how you figure out like which goes where in RAM basically. You can see that this is a Windows 10 image that I took this from. And it looks like that's just about it. Well, it does say the P time die. Not sure what that is, but I believe that's the. I'm not sure what that is, but oh, system time. That's what I was looking for. I was going to say that was the. I was going to say this one was the system time, but that's not true. This one's the system time, so that's about when I acquired this image, the 24th at around 7:30. Okay, and you can see that that was a 32 gigabyte image that completed. I mean, I did cut it out a little bit, but it was really only like less than a minute. So Volatility 3 is really what you want to use for going forward, I think. So it helps to kind of get used to this one early, I think. So how do we install Volatility 3? Well, it's a little different than Volatility 2. There aren't binaries for Volatility 3. I will. Where do they have their releases here? Releases. Okay, so in their releases, all they really have is this .wheel file. What a wheel file is, for those who maybe don't know Python that well, that is a link to a Python package. So what you'd want to do is, well, if you're using this, if you're doing it this way, is download this wheel file and then do a pip install on it. In my case, I felt like it's just better to just download the source code. It's easier to access that way anyway, and I could, like, you know, if I really want to, I could make edits to it. I don't think I ever will. This stuff's complicated, but you could if you wanted to. So what I would recommend you do for install, well, first, before we go into install, first make sure you have Python installed. You're going to need that to be able to run it. So pause here and go download Python if you don't have it installed. But for those of us who do, we're just going to go ahead and clone this URL here. So I'm on my desktop. You can see I already cloned it, but the command that you're going to want to use is something like git clone volatility3.git, and that's going to pull it into that volatility3 folder. What you're going to get in that volatility3 folder is the vol.py script. Yeah, I call it a script, I guess. So there's the vol.py script there. And there's this requirements file that's going to list all the packages that you need in order to run it. So for me, I did -r requirements. So for most people, this is all you're going to really need to do first is pip install -r requirements. I believe for me, so I'm a special snowflake and I use Debian SID, so they are apparently moving towards not allowing you to do pip install to your main repo. So if you get this little error message, you're going to want to just use this little break system packages flag. It's not going to actually break anything. You'll be okay, I promise. But you're going to do pip install break system packages requirements.r. Right, and then it'll allow you to download. In my case, it's just, I already downloaded all this stuff, so it's just going to spin. Oh, I guess I didn't download everything. Probably some extra stuff that I missed. All right, once that's all done, you are now ready to use Volatility 3. So you already saw that it works, so I don't need to show you it again, but the first thing I would recommend doing, well, before we get there, let's talk about organization first. So we have this little Volatility 3 folder. I'm going to stick a head of that folder so that way I can run it with Python volatility3 vol.py. So the first one you're going to probably want to run is just -h for the help menu. And there's a lot of options, so I'm going to pipe this into less so I can page through it. If you're on Windows, you could use more. All right, so the basic options you're going to want to know is F for file. You're going to want a file to analyze, of course. That's going to be the path to your RAM image. Most of these other ones I'm not too sure about. Well, I know. O is an output directory. If you want to output files, you're going to want to supply that one. We'll see how that works in a little bit. And the rest is just kind of alternate directories. Most of this you don't have to change, so if you have other volatility plugins you use, you can use the -p option. If you have other symbol table files somewhere else, you could use the -s. But for the most part, you can just use what's packaged with volatility. So let me just page through all this stuff because this is less interesting than the plugin list. So these are the options that Volatility has for analysis. These are the kind of things that it can grab out of RAM. As you can see, there's a lot more than 4 I can get here, right? So the question only asks for 4, but I can get a whole ton of stuff. If you have a Linux image, you could get Bash, you could check syscalls. You could check your ELFs, environment variables. That might be useful. You could see what's mounted on the system right here, linux.mountinfo. And you have similar options for all the operating systems. So you have kind of similar ones for Mac, where it applies. And since this is a Windows image, these are the tools we're going to want to focus on, these Windows tools. Just to clean that up a little bit, I'm going to grep out Windows just so we can look at those in particular. All right, so the basic Windows options, just to highlight a few, the command line is going to give you any command line options that were run while the image was being taken or before the image was taken. You can dump out files from the RAM. So if there's RAM that's, if there's files inside the RAM that you want to retrieve, you could get that from there. File scan will tell you the active files that were being used. And we're kind of going to go through a few of them. Right, so that's how you would look at your modules that you have. Let's take a look at where I'm at. Okay, so we covered how to download and how to run Volatility 3 with Python. Oh, I do want to make a quick note on symbol tables. All right, so I ran into, well, I didn't run into this. Well, I ran into this first with a virtual machine image. So what I did for this demo is I was going to use a VirtualBox image, like something like, I'll show you real quick. Where did VirtualBox go? Oh, there you are. You're up here. Okay, so I was going to do something like just run Windows 11 and do a RAM capture that way. For some reason, Volatility didn't like that. It didn't find any symbol table files that were relevant for it. So I don't know if that's a thing specific for virtual memory. I assume it is. But if you do get like a symbol file table missing thing, when you run this, specifically when you run this image, run it again. This command, right, with the Windows info command. If you run into like a missing symbol file table thing, you might want to look at, you're going to want to maybe check out this little link here for Windows symbol tables. You may have to download the symbol tables manually if it's not for the image that you are looking at. So I have a Windows 10 image here. You might be working with Windows 11 or something like that. If you want to add extra symbol tables that might be missing, you're going to want to clone this repo and just follow the commands here. Right? You're going to want to basically copy the symbols directory that is in this GitHub to the Volatility symbols directory. Show you where that is real quick. ls volatility /symbols. Oh no, sorry, Volatility 3. That's where it is. And that's going to be Volatility 3. So Volatility 3 /Volatility 3 /symbols. You can put it as a zip file here. Volatility will unpack it for you. So you could just put it right as a zip file if you really wanted to. Or you could follow the commands that this guy's doing. Okay, so now that the basic reading images and all that stuff's out of the way, let's go on to some fun analysis, right? Let's do some useful stuff. So the ones that I found kind of easy to digest and simple to kind of run were these commands. And for the benefit of time, I ran these commands ahead of time. I'll show you the basic syntax that I'm using. So if I do Python volatility 3, blah, blah, blah. First, you're going to do -f for mem.raw. And then for the command line plugin, right, I just pipe this to a file, right? So I send all the output to a plain text file. And what I did is I put these all in the recover directory to kind of make it simple for me. All right, so I'll show you the commands first and then kind of show you what the output is. So first is this command line command. That will show you what commands might be running on the system. So now that that's in a file, let's go ahead and kind of search for some interesting stuff. So in this particular image, I had a few programs open. I was pinging my website. I had my website open in a browser, and I had an image of a cat open in MS Paint. So let's see if we can find hints of any of that stuff in the command line folder. Yeah, let's just less it. Let's just see how big it is. Right, less command line to page through it. Okay, you can see some kind of familiar stuff here. Registry stuff, Windows startup processes, things like that. All right, so a lot of garbage that you kind of want to pin through. Let's go ahead and grep out, grep not. What was that big? I always forget the name of this one. Let's get rid of LSAS, service host. Yeah, let's start with that. That should get a lot of it. All right, so we will grep not, service host, grep not Success. Okay, what else do we have here? Well, you can see that Windows Terminal was open. That's an interesting one. That's not going to be on every system. So you can see I was opened with the terminal in my desktop. I had PowerShell running at the time. Let's see what else we got here. That's interesting. We can see that MS Edge is open. Okay, so that was open at the time of the system. At the time the system was shut down, or rather, the time the memory was acquired, more accurately. We can see I have Discord open, so we could learn a little bit about a Discord user from that little command line option. There's MS Paint, so we can see that one was running. I'm curious, can I get the ping command? I was trying to grep this before and it didn't come out. I don't think it's in here, which is kind of disappointing. I was really hoping it would be. Try to grep for ping. Oh, you know what? Actually, it could be capital, so let me insensitive. So ping wasn't there in the command line options, but that could be just because it got overwritten by something else. Maybe there were other commands running. That's the thing about volatile memory, right? It changes a lot, so you could very easily kind of lose stuff that might be running at the system. But that's okay. We have tons of other options to kind of go through, and maybe we'll find it there. All right, but you can see just from looking at command line stuff, we learned a lot about the processes running on the system. Especially if you were looking for malware, this would be super helpful because malware is going to be spawning a whole bunch of weird stuff that you're going to see here. The next command I wanted to go through was the netscan command. So this is going to show you active connections on during the time the image was acquired. So let me see, I have that one stored in recover /netscan. And this one seems to be a particularly long command to run. I'm guessing because it includes all these localhost connections. It's a whole lot of stuff. Let me just see if I can find the ping command here, because that's really what I'm interested in. So let me see if I can grep insensitive ping. Really? That's so surprising. Well, I know I was connected to my website. Do I have my host name there at all? I don't have that, but maybe it have the IP address of the site. That's going to be this guy. Let me try grep that IP address without the parentheses. Okay, that one's not there either. All right, let's just kind of go through this and see what connections are on the system then. Let's grep out all the 0.0s. I think that's going to help clean this up a lot. So let's go ahead. Let me also zoom out a little bit and grep out the zeros. So grep not 0.0.0.0. All right, that should clean it up a little bit and pipe it into less. I still have localhost connections and IPv6, so let me go ahead and grep out those two. Grep not. And grep not 127.0.0.1. Pipe it to less. Okay, so these foreign addresses you're seeing here are probably all Microsoft addresses. That's kind of the thing I always hate about Microsoft images, because it's always talking to something, which kind of makes for a lot of noise. But you can see the IP address of the system, at least. All right, had a quick call I had to take. All right, continuing on with our analysis here. Yeah, it looks like there's unfortunately no connections to the outside world here, which I'm really disappointed to see. I don't know why that wouldn't show up in the image. Well, that was a disappointing demo, but you can get an idea of the kind of net commands that are being run on the system that way. Just a quick note there. So the command is Python Volatility 3 f mem.raw windows.netscan. I piped that to netscan. The difference between netscan and, say, something like netstat, this will actually give you the output of the netstat command, which maybe have less information. The scan is always going to get, it's going to look for raw IP addresses and like network connections in the image itself. So we go ahead and pipe netstat, for example, and this one I'm running raw because I didn't do this one before. Right, you see an output that's pretty close to what the netstat command is going to give you, and you can see a lot of the same info here. Okay, so that's the difference between those little net commands. Next one I want to show is the process scan. This is kind of the big one. So the big benefit of getting a memory image is that you can look at processes running on the system at the time. And that can give you a whole bunch of information. Files that might be temporarily accessed or things that just might be running that you want to know more about. So that one is going to be this command, windows.psscan to psscan. And let's go ahead and grep that file. Well, let's less it first. Less recover psscan. Look at what we got. Okay, you can see a lot of the same processes we saw before, service hosts, all that nonsense. Ooh, you can see I have an NVIDIA on this device. That could be a helpful little thing. Let's do the same thing we did before. We were grepping out service host and all that other nonsense. Grep not service host. Grep not LSAS. Let's see if that's enough. Oh, I should have. Whoops. I could have grepped first, but whatever. What else do we want to move out of here? Well, I can't think of anything else to take out, but oh, we found ping. All right, so now we know that ping was running on this machine. That's what I was looking for. All right, so that shows you that sometimes you just kind of look at different parts of the memory to find what you're looking for. Right, it might be in memory somewhere else that you didn't think about. You can see Windows Terminal is open. I'm guessing this one, they're pretty close. That's kind of a correlation there. And we have Explorer.exe, so we know we were looking at files at the time that this image was being run. I think that's all we're going to find that's interesting there. All right, now let's take a look at files that we might find references to in memory, or perhaps full files we could recover from memory. We're going to look at the file scan and the dump file commands for this. But first off, how would we find images in memory in general? Well, if you just had like a hex editor and you kind of went through it, right, you could just search out a signature in the file. So if I go over here and go to file signatures, I tried searching out this in another video. I don't know why it didn't work. It should really work, but I'm going to what did work was I just searched JFIF, which is kind of like the text version of that file. And if I just search for JFIF, we find our first image over here. And you can see that little file signature is right there, so I don't know why I didn't find it, but whatever. So if we were just covering for files manually, we might just kind of copy all this stuff until the image ends. Does the image have any? Oh, it looks like it ends kind of over here. Some extra bits in there. Let's say it ends over there, just for the sake of argument. Copy it, make a new file, paste all the bytes, save it, go to desktop, recover, and we'll call it this.jpg. I did that before. Replace it. That is not where I wanted to go. Let's go to the desktop. Go to recover. And you can see we recovered that little Microsoft thumbnail. You can see it's a little corrupt, so maybe this was kind of only in memory for a little bit and kind of got stuck there. But it gives you the idea of the kind of stuff you can get from memory. How can we actually get a list of files that are on this image? Well, Volatility, instead of doing Control F a million times, you have Volatility, right? So we're not going to use a hex editor for this part. Let me go ahead and close out all this and go back to here. Right, so I already ran the file scan command here, which is going to look something like this. File scan to a text file. And let's just look at what that file has. Let's recover file scan. Okay, and you can see both the path to the file and this little address here. Now, this kind of confused me at first, so what I found was this little cheat sheet. I'll include this in the description. That kind of goes through the plugins that Volatility 3 and how to use them. So if you see at the file dump command, right, it asks for either a virtual address or a physical address. So the physical address is like what you see in Bless, right? If you try to, well, I'll show you, right? So if I try to like search for this physical address in Bless, let me try to bless that file again. All right, and I search for this, now I got to go to offset and search the offset. You're going to see that it's outside the file's limits. The reason for that is that a virtual address, right, when a process runs, the operating system adds kind of like a random little offset to it. There's security reasons for that. There's other reasons for it. I won't go into that in that video. But the basic idea is that the virtual address has an extra, like, sequence that you add onto the physical address. So what Volatility gives you is going to be the virtual address for the most part, Right, so this address over here tells you the offset you can find that file. Let's go ahead and try to find some interesting files here. Let's see if we can find that picture of a cat that I mentioned before. So grep jetpig. Okay, we have some images open. We see Steam is installed. That's a nice little tidbit that we learned. And where is the image I care about? Well, we can see my wallpapers here. Here we go. This is the image I think I was looking for, because that looks like a screenshot or something. Like it has the date of the image that was taken. All right, so that happened at this virtual offset. Let's see if we can use the dump file command to recover it. So it's going to be Python 3 volatility windows.dump files. And let me just refer back to my cheat sheet. We're going to want the virtual address vert ADR, this guy. And let's go ahead and put it in the output. Let's put it out in the recover folder. All right, let's go ahead and run that command. Let's see if we get that picture back. Okay, and you can see that it outputted the file, and it named it a random kind of thing. It named it after the object in question. Let's go ahead and go to recover. You can see that I have a cat right here, right? So that is probably just a thumbnail. So you see when I open this, I'm going to get some weirdness. It looks like there's pieces missing to the file. So this was probably just a thumbnail that got saved in image. But sometimes that's all you really need, right? Just to show what was in that file at the time it was running. Okay, so that's how the basic idea of how we can recover files from memory. Last one I kind of wanted to mention, you can also get registry info here. This one I'm running raw. So let's just go ahead and run it and type it to less, see what we get. Less. Okay, now that's finished. You can see all the keys that are on the system. Windows registry analysis is kind of a topic in itself, so I'm not going to go super into like what keys might be interested here, but you can see that pretty much everything got dumped here, right? We can just kind of go through it and look for keys of interest, grep out keys of interest. All right, and that wraps up the intro to the basic plugins Volatility 3 has. I was hoping to wrap up the video here at Intro to Volshell, but it looks like the video is already a half hour anyway, and I don't want to keep anybody longer than that. So maybe this will be a video for another time. It's a pretty cool thing. It basically lets you run the image in Python and kind of work through it. I still got a little bit more to do on this, so maybe that'll be a future video in a month or two once I actually learn it. That concludes this video. If you hope you liked it. If not, leave me a comment. Let me know what I can do better next time. Thanks for watching, people.